At sunrise, thousands of robots already begin working while most of the world is still asleep. These machines do not complain, rest, or stop when temperatures become unbearable. They plant seeds with millimeter precision and analyze every square meter of soil in real time. What once required entire farming crews can now be done by a single autonomous machine. This is not science fiction anymore. It is the beginning of the biggest transformation agriculture has seen since the invention of the tractor. And the reason behind this revolution is far more urgent than most people realize. Humanity is running out of farmers. In many countries, the average farmer is now older than 50 years old. At the same time, global food demand continues rising toward nearly 10 billion people. The world suddenly needs more food, with fewer human hands available to grow it. That pressure created the perfect conditions for intelligent agricultural robots to emerge. Traditional farming depended heavily on human intuition and physical labor for thousands of years. Farmers learned weather patterns by observation and protected crops through experience passed across generations. But modern agriculture became increasingly industrial, complex, and brutally competitive. Profit margins shrank while fertilizer, fuel, water, and labor costs exploded. Then, climate instability added another dangerous layer of uncertainty. Farmers suddenly needed to predict disease outbreaks, optimize irrigation, and reduce chemical waste at impossible scales. Human workers alone could no longer manage millions of individual farming decisions fast enough. That is when robotics engineers saw agriculture as the next major frontier for artificial intelligence. Instead of building machines that simply followed commands, they built systems capable of analyzing the environment around them. Cameras became robotic eyes. GPS became robotic navigation. And machine learning became the robotic brain behind the entire operation. Some autonomous tractors can now drive through fields for entire days without a human touching the steering wheel. Using satellite positioning accurate within centimeters, these machines follow perfectly optimized routes. Every unnecessary movement wastes fuel, time, and money. Intelligent robots are designed to eliminate that waste entirely. In vineyards, robotic machines now inspect grapes one plant at a time. Computer vision systems identify color variations invisible to the human eye. Those tiny differences can reveal disease days before visible damage appears. Other robots move slowly through vegetable fields, targeting individual weeds with microscopic precision. Instead of spraying chemicals everywhere, they attack only the exact plants that threaten production. Some systems reduce herbicide use by more than 90%. That single improvement could reshape the environmental impact of industrial farming. And then there are the harvesting robots. These machines perform one of the most difficult tasks in all of agriculture. Picking fruit sounds simple until a machine must distinguish ripe produce from unripe produce instantly. One mistake can destroy fragile crops worth thousands of dollars. Yet modern robotic harvesters are becoming faster and more accurate every year. The real power of agricultural robotics does not come from hardware alone. It comes from data. Every robot constantly collects information about soil moisture, crop growth, temperature, and disease risk. Drones flying above fields add another layer of intelligence. From the sky, AI systems can identify stressed plants long before humans notice anything unusual. Some farms now generate more digital information in one season than entire industries produced decades ago. Algorithms analyze that information to predict exactly when crops need water, nutrients, or protection. This approach is called precision agriculture, and it is turning farms into giant outdoor computer systems. In some advanced operations, farmers can monitor entire fields directly from smartphones. A single alert can warn them about insects, irrigation failures, or nutrient imbalances instantly. Farming is no longer only physical labor. It is becoming an information war against uncertainty. Governments and corporations understand that whoever controls food technology gains enormous strategic power. Countries like the United States, Japan, China, and the Netherlands are investing billions into agricultural automation. Some vertical farms already operate, with robots moving 24 hours a day inside controlled indoor environments. These facilities use dramatically less water while producing crops close to major cities. In Japan, strawberry picking robots were developed partly because labor shortages became critical. In Australia, autonomous machines help farmers manage enormous remote properties impossible to supervise manually. And in Europe, sustainability regulations are accelerating investment into precision robotic systems. The competition is not only about efficiency. It is about securing future food supplies during an unpredictable century. But every technological revolution creates new vulnerabilities. Critics warn that intelligent farming systems could make agriculture dangerously dependent on software. A cyber attack against major agricultural networks could disrupt food production at massive scale. Others fear small farmers may struggle to afford increasingly expensive robotic technologies. Large corporations could gain even greater control over global food systems. There is also the human question. What happens when millions of agricultural jobs become automated? Some experts believe robots will assist farmers rather than replace them completely. Others believe agriculture may eventually become one of the most automated industries on Earth. The final outcome remains uncertain. Even with all the risks, intelligent agricultural robots may become essential for human survival. Climate change continues reducing predictable growing conditions around the world. Water shortages are forcing farms to become more precise than ever before. Artificial intelligence can optimize resources at scales impossible for humans alone. Future robots may eventually pollinate crops, repair damaged plants, and coordinate entire farms autonomously. Some researchers are even developing swarms of tiny farming robots inspired by insects. These machines could monitor every individual plant across entire continents. Agriculture is slowly transforming from mechanical labor into planetary-scale computation. And most people still have no idea this transformation is already happening. The food on future dinner tables may come from machines that never sleep. One day, historians may look back and realize humanity changed agriculture forever without fully noticing it. Because somewhere right now, beneath the rising sun, another intelligent robot has already started feeding the world.